Today we're going to talk about combining transformations. So we're going to look at the order of your transformations and also writing them out, and then the next day we'll talk about graphing them. So for our general equation, we have g of x equals a times f of b, x minus h plus k. So remember, g of x is the transform function that we talked about before in our graphic organizer, and f is the parent graph. So when you are graphing these, you're going to always graph the parent function first, which in this case would be f of x, and then you're going to follow the order of operations when graphing the transformation, so PEMDAS. So if we look at this equation up here, normally it's always written in factored form, but if it wasn't in factored form, we would have a times f of bx minus bh plus k. So we always just leave it in factored form because that stretching or compressing is for the b value. It just makes it easier to tell how you're moving left or right. And so notice that if you think about your order of operations, you always do things in parentheses first, multiplication, division, then addition, subtraction. And so in this case, we have b would be our first transformation. So we know that if b is less than 0, it reflects the graph over the y-axis. We also know that b is going to stretch or compress the graph horizontally by a factor of the absolute value of 1 over b. Remember, we have to do the absolute value of the number because the negative is the reflection. And then that h is going to shift the graph horizontally h units. If it's bigger than 0, it moves it to the right, because that would be x minus h. And if it's less than 0, it moves to the left h units, because this would be x minus negative h. And so that becomes x plus h. So remember that your horizontal movements are always opposite thinking, and they change your x value. So remember that delta just means change in, so change in x on your graph. Then we have our vertical movements. So we have our a value, which is on the outside. So if a is less than 0, it reflects the graph over the x-axis, or it's going to stretch or compress the graph vertically by a factor of the absolute value of a. Again, notice the absolute value because the negative is reflection. And the k value just moves our graph up k if it's bigger than 0, or down k if it's less than 0. So when you're moving stuff up and down on your graph, remember that's changing your y on the graph. So again, we'll look at actually graphing these on the next day. So we have our general equations over here in this box. And so for your general equations, we've talked about linear, quadratic, cubic, square root, etc. So you can see where each of the different variables is for the function. So things attached to x are normally in parentheses. For quadratic being squared, everything on the outside is a vertical movement. Same thing with cubic. Things on the inside of the parentheses being cubed is a horizontal movement, a and k, notice on the outside. If you look at the square root function, you can see that the b and the h are underneath the square root. Same thing with the cube root, and also on the inside of the absolute value bars. So those would be your horizontal movements, and on the outside is going to be your vertical. Exponential, the exponent, the b and the h are with that. A and k are on the outside. Rational would be in the numerator on the outside for your vertical movements, and notice b and h are in the denominator with x. And logarithmic, your vertical movements are on the outside of the log, and your horizontal movements are on the inside. So try not to use those equations too much when you're writing them out, because you don't want to become dependent on having to look at that all the time, but it will help you when you just get started. So we've already looked at this graphic organizer and talked about each of the different transformations. So we just talked about these up here, and we didn't specify for the stretching or compressing, which we can look at again. So if the absolute value of a is greater than 1, it's a vertical stretch. If it's in between 0 and 1, it's going to be compression. If the absolute value B is bigger than 1, it's a horizontal compression, and if it's in between 0 and 1, it's a horizontal stretch. Remember, those are the opposite thinking that we have. And so I'm not going to go over this too much because we've already looked at that on the other notes that we took. So again, remember that your horizontal transformations change the x values and vertical transformations are going to change your y values. That's very important for when we are graphing these. So take a moment to pause the video and then write down the different transformations. Try not to look at them to see if you can actually write them out. And then are they changing x or y? And when you're done, you can unpause and we'll take a look at our work. All right, so that first one, notice it's a b value. It's on the inside attached to x and it's being multiplied, which tells us this is a horizontal compression by the absolute value of 1 over b. And remember, horizontal movements change your x. So this is 1 over b. So 1 over b is going to be a number in between 0 and 1. So this one's going to be a horizontal stretch by the absolute value of 1 over b. So again, you're going to change your x. The negative here is on the inside attached to x. So this is going to reflect across the y-axis. The next one, notice the negative is on the outside. So this reflects across the x-axis. So this is a change in y. The last one was a change in x because it was a horizontal movement. And now we have the a, and it should just been times f of x. I don't know why that g is there, so that's just multiplied. So a times f of x. So that a is going to be a vertical stretch by the absolute value of a. So again, we're changing our y's. So again, that's supposed to be a multiplication sign right there. So for this next one, we have a vertical compression by the absolute value of a. So again, changing your y. So now notice that the h is on the inside of the parentheses, which means this is going to move the graph right h units. So again, moving left to right, remember, changes your x. This one moves it left h units. So again, changing the x. And the k is on the outside. So this one moves it up k units, changing the y, and down k units, again, changing the y. So that's just a description and the change in x or y. So looking at this next part, it says we want to name the parent function and describe the transformations made in order. So for this one, we know that this is was not written on this little information over here, so we can just go ahead and write it out. We know this is the parent graph, of course, is y equals the sine of x, which of course is trigonometric. And we just did our unit on this, so we have the equation would be y equals a times the sine of b times x minus h plus k. So notice that for this one, this is our a value, this would be our b value, and this would be our k value. In this case, we don't have an h. So our b value is what we always start with because we want to follow the order of operations. We do our things inside the parentheses attached to x. So notice that the order I'm always going to be following is b, h, a, k. So b in this case is 4. And so if you need to go back to your graphic organizer and look up here, so if our b value is less than 0, it reflects across the y-axis. It's not in this case. The absolute value b is bigger than 1, which tells us it's going to be a horizontal compression by 1 over b. So in this case, this is a horizontal compression. That's what HC stands for, by 1/4. Then my h, if it's not written, well, and you're adding or subtracting a number that doesn't change the equation. In this case, that would be 0. So h is 0, which means there is none in this case. No transformation for left or right. And for the next one, we have a, which is 3. So again, if you need to go back at your graphic organizer, a is not less than 0, so we're not doing reflection. And the absolute value of a is bigger than 1, which means it's a vertical stretch by the absolute value of a. So the absolute value of 3 is 3, so this is a vertical stretch by 3. And then my k value is 2, which moves my graph up 2. So again, we're just practicing writing out the steps because this is going to be helpful for when we are going to graph these on the next notes. So remember, this is the change in your x's, and a and k are the change in the y's. So remember that the b and the h are always opposite thinking. So that 4 you might think is a horizontal stretch, but remember it's a horizontal compression. So looking at the next one, we have, again, a sine equation. So if you want to look at your general equation up here, you can see that your a, in this case, is here, this is b, and we don't have an h or a k. So your parent graph is still y equals the sine of x, and it's still trigonometric. You can write trig function. So b, in this case, is 1/2. So again, if you go back to your graphic organizer, b is not less than 0, so we're not reflecting. But in this case, it is in between, the absolute value is in between 0 and 1, so that means it's going to be a horizontal stretch by 1/b. So that means this is a horizontal stretch by, and what's 1 divided by 1/2? Well, keep, change, flip. So that gives us 2, so horizontal stretch by 2. Your h, if it's not there, is 0, so that means there's none. A, in this case, is -1. So if we go again back to our graphic organizer, when your a value is less than 0, it's going to be a reflection across the x-axis. And then for the other two, notice that the absolute value of a is not greater than 1 because the -1, the absolute value of that is 1, which is equal to 1. So when it's 1, we're not stretching or compressing our graph because 1 times anything doesn't change the value, right? So in this case, we're only reflecting it across the x-axis. And then your k value, if it's not there, of course, is 0, which means none. So again, b and h change your x values, a and k change your y values on your graph. So the next one we're looking at is the cosine equation, which is very similar to our sine equation. So your a value would be on the outside. This is your b, h, and k. So your parent graph is y equals the cosine of x now, and it's still a trig function. And so b, in this case, is equal to 3. H is equal to 2. Notice I didn't put -2 because it's always the opposite. If it was negative, then this would be a plus on the inside right here because that would be x minus -2 to get that plus. So the original equation is always minus, so 2. A, if it's not there, of course, is just 1, and k is 1 as well. So for the first one, the absolute value of 3 is bigger than 1. So since it's bigger than 1, if you need to go back and look here, that tells us it's going to be a horizontal compression. So we don't have a reflection, just a horizontal compression. So horizontal compression by the absolute value of 1/b, so 1/3. 2 means we're moving to the right 2. My a value is 1. So unlike when you're doing the h and the k and it's not there, like the last problem, notice it was 0 because 0 plus or minus anything doesn't change the equation. Well, when you're talking about your a and your b value, if it's not there, it's 1. and 1 times anything doesn't change your equation. So because 1 is not less than 0, and it's not, the absolute value of this is not bigger than 1 or in between 0 and 1, so that means this one doesn't do anything to my graph. And the last one, k is 1, moves it up 1. So those again are just the transformations. So if we look at the next equation, again, I can go ahead and bring this down to help. So if I look at these next equations, try to see if you can do 4, 5, and 6 on your own. When you're done, unpause the video and we'll take a look at your work. So looking at that first equation, we can see we know it's a square root function. And you can use that middle, this equation where it says a square root to help you figure out what the values are. So we know that the parent graph is y equals the square root of x. And again, it's the square root function. So that means this is my a, my b would be in front of my x, h, and k. So again, here's the square root function. So for this, b, since it's not there, it would have to be 1, because 1 times anything doesn't change the equation. Unlike 0, you wouldn't want to write your b value 0, because that would be 0 times something makes it 0. So b is 1, h is 3, a is 4, and k is 8. So if my b value is 1, then 1 is not less than 0. So if we go back up here, so 1 is not less than 0, so there's no reflection. And again, the absolute value of 1 is 1, which is not bigger than 1, and the absolute value of 1 is not in between 0 and 1 because it's equal to 1. So that means there is no transformation being made on that b value when it's just 1. So this would be none. For 3, that's going to move it right 3. 4 is my a value, so it's not less than 0, but it is the absolute value bigger than 1, which is a vertical stretch by 4. And when k is 8, that moves our graph up 8 units. So looking at the next one, we notice we have that square there, which tells me this is going to be a quadratic equation, y equals x squared. So we have the general equation. You can use your little cheat sheet, or I would just get in the habit of, if it helps you out, writing it out. So this would be a, and then times b times x minus h squared plus k. So that means my b value is 7, my h is 1, a is -1/2, and k is 3. So if b is 7, this is going to be a horizontal compression by 1/7. Again, if you need to use your graphic organizer to help. It's not less than 0, but because the absolute value is bigger than 1 is why it's a horizontal compression. Remember, opposite thinking. So then for the next one, h is 1, which is going to move it to the right 1. A is -1/2, so we go back up here. If a is -1/2, then notice that it's less than 0, so it's a reflection over the x-axis, and the absolute value of 1/2 is in between 0 and 1, so it's also a vertical compression. So now we have 2 transformations. When that happens, which we'll talk about when we're graphing, normally I do the reflection first and then stretch or compress, but it really doesn't matter what order you write it in. So for this one, we would reflect across the x-axis, and we also have a vertical compression by 1/2. Notice I didn't put the negative there, so the negative was a different transformation, the reflection. And just as a reminder, if you go back up here, notice it's always vertical stretch for vertical compression by the absolute value of a. And so then that last one is that 3, which is going to move your graph up 3. So then the next one, I see the absolute value bar. So that tells me y equals the absolute value of x is my parent graph. So absolute value. So this is my a, my b would be in front of my x. This is my h, and my k. So b, if it's not there, it's 1. H is -1 because notice it's x plus 1. So to get that plus 1, it has to be x minus -1 to get that to be plus 1. So that's why H is -1. A is 1/4 and K is -10. So if my B value is 1, that doesn't do anything to my graph because 1 times anything doesn't change it. H is -1, which moves it left 1. A is 1/4, which is a vertical compression by 1/4. And K is 10, which moves your graph down 10. All right, so again, see if you can pause the video and do these 3 on your own. When you're done, unpause, and we'll go ahead and take a look at your work. So for question 7, this, of course, parent graph is y equals 1 over x, which is a rational function, which we've been doing our rational functions. That was in unit 4. So for this, we have y equals a over b times x minus h plus k. So that means that my b value is not there, so it's 1 because there's nothing being multiplied in front of the x. H is 8. A is -12 because it's in the numerator, and k is on the outside, which is 17. So this doesn't do anything to my graph. We move this one right 8. This is going to be a reflection across the x-axis and also a vertical stretch by 12 and then up 17. Because remember, if your a or b is negative and a number besides 1, or of course if we don't want it to be 0 either, it's going to be stretching or compressing. For the next one, we have the parent graph, which is y equals the cube root of x. So this is a cube root for the name. So the general equation is y equals a times the cube root of b times x minus h plus k on the outside. So in this case, your b value is 3. H is not there, so it's 0. A would be 5, and k would be 0 as well because we're not adding anything on the outside. So the 3 means this is a horizontal compression by 1/3, because remember, opposite thinking. This doesn't do anything to my graph. This would be a vertical stretch by 5, and this does not do anything to my graph. Looking at the next one, we have, again, parent graph is the absolute value of x. So y equals a times absolute value b times x minus h plus k on the outside. So my b value is -1/8. My h is equal to 1. A is 1 because there's nothing being multiplied on the outside. So if you want to put that 1 placeholder there, you can. And k, of course, would be 0. So again, these two transformations, because we have the negative and the 1/8. So again, if you need to go back up here and look at your graphic organizer, if b is less than 0, it reflects over the y-axis, and the absolute value of b is in between 0 and 1, so it's a horizontal stretch by 1 over b. So again, this is going to reflect across the y-axis, and it's going to be a horizontal stretch by the absolute value of 1 over b, so 1 over 1/8 gives us 1 times 8 over 1, which of course is just 8. So horizontal stretch by 8. This moves it right 1. When a is 1, 1 times anything doesn't change your graph, so this doesn't do any transformations, and neither does the plus 0. So like I said, it is important to know the order. That's why we're practicing just the steps, so the B, H, A, K, and the transformations, because when we are going to be graphing these, we're going to graph each of the transformation steps, which is why it's important to know that your, again, B and H are going to be changing your X's, and A and K are always changing the Y's, because that's what we're going to need to do this by hand when we are graphing. So for these next ones, it says, transform the given function f of x as described and write the resulting function as an equation in terms of g of x. So now I'm giving you the transformations, and we're going to write the equation. So of course this first one is x cubed, which is the name for that is cubic. So it's the cubic function. So we're doing a horizontal stretch by a factor of 3. So horizontal stretch means that's your b value, right? So that means that b would be equal to 1/3 because it's a horizontal stretch by 3. Remember, it's always opposite. So to get that 1 over b, you would have to do the reciprocal of the number. Translate right 3, so that means h is equal to 3 because we'd be going to the right. Reflection across the x-axis means my a value is -1, and translate up 1 unit, so that means k is equal to 1. And again, if you need to use your graphic organizer to help you right now, that might be a good idea, but again, try not to use it all the time because you don't want to become dependent on it, but for now it might help. So now that I have each of these, I can go ahead and start to put this in my equation. So my general equation would be y equals a, and then b x minus h. All that would be cubed plus k. So g of x is equal to, we said our a was -1, and then our b is 1/3. So 1/3 times x minus my h value, which is 3, all cubed plus 1. So this is my transformed graph. So if we look at the next one, this of course has the square root. So it's the square root graph. We have a reflection across the y-axis, so that means b is equal to -1. Translate left 3, so h equals -3 if we're going to the left. Vertical stretch by a factor of 2, and reflection across the x-axis. Those are both your a, so a is equal to -2. Negative is the reflection, and the vertical stretch is the 2. And up 3 would be k is equal to 3. So for this equation, we have y equals a times the square root of b times x minus h plus k. So that means we get g of x is equal to -2 times the square root of -1 times x minus -3. That becomes +3. And then k is 3, so +3 on the outside. So that would be my transformed equation. So notice your b and your h are underneath the radical, and a and k are on the outside. And again, the +3 means we're moving it to the left 3. Remember, opposite thinking. So then try to see if you can do 3 and 4 on your own, and when you're done, you can unpause the video to check your work. So for question 3, I see a square, so of course this is a square root. Horizontal compression by a factor of 1/2 and reflection across the y-axis. These are both b, so b would be equal to negative, and then since it's a horizontal compression by a factor of 1/2, again, remember horizontal compression is when your b value is bigger than 1, so you're just doing the reciprocal of 1/2, which is 2. So b equals -2, and translate to the left 4 would be an h of -4. So for this, my general equation is y equals a times b x minus h quantity squared plus k. So in this case, g of x is equal to -2 times x plus 4 all squared, because remember our a value was not there, so 1 times anything doesn't change it. So if you want to put a 1 in front, you can, but it's not necessary. And then the k value, of course, was 0 because we didn't talk about moving it up or down. The next equation, of course, is absolute value, because we see those absolute value bars. So we're translating it to the right 2, which means h equals 2. Vertical compression by 1/5 and reflection across the x-axis means my a value is -1/5. And translate it right, or excuse me, down 5, which means k is equal to -5. So our general equation, y equals a times the absolute value of b x minus h, close absolute value bars, plus k. So I just need to put my variables into the equation. So -1/5 times the absolute value of b, which we don't have. So it would just be x -2, close absolute value bars, and -5. So that means of course, your b value is just 1 if it's not there. but we don't need to write that 1. So this would be my new equation. So again, first we're just practicing writing out each of the values, going from the transformation, writing the equation, and also given the equation, can we write out the transformations? And like I said, you can use your graphic organizer to help you now, but I would get in the habit of trying to do it without looking at this and then just using this to check your work when you're done. Same thing with our little cheat sheet of the equations that we had written out, which are also at the top here. So that is all for today, and the next notes we will actually be graphing each of these functions out by hand.